Very first thing, I got notes on here already. Where are your notes? That could be something that could come in handy. I'm going to show that as we go through here. Because again, you get to use them. Are they done? If they're not, the notes are updated online. I got a paper copy up here too I'm willing to let you borrow. And they're not going to do you any good if you're spending 5 minutes looking through all the notes trying to figure out where are the notes for this. I don't know because you've never used them. So one of my goals today while we're doing this is going to be to show you where these things are so you can kind of start to think about how this is going to work. Okay, first part, we're all exponents. This seems like forever ago, but it's not. So simplify. Your answer should only contain positive exponents. What I'm going to do is I'm going to deal with, I'm going to deal with 2 and 4. I'm not going to go crazy with these. But I do want you to kind of be able to feel out some of the things that we've got to do. So when we're trying to find exponents, it's right in the front of your note packet. Mainly what I need here is just going to be, thank you, is going to be the basics. Multiply is add, power to power, parentheses is multiply, divide is subtract. Right on the front. So when I start taking a peek at number 2, which is where we're starting, we are going to, if there's parentheses, normally I just deal with that right away. You have options here, but we're going to multiply that 3. Hardy, there's no exponent on the x. Oh, there's an exponent there. It's just 1, so don't forget about that either. So if I do all that right off the bat, so 3 times 3 would be 9. Negative 2 times 3 would be negative 6. 1 times 3 would be 3. And negative 1 times 3 is negative 3. Now you have options. If you want to go ahead and just add exponents, because this is all multiplying at this point, I can just add exponents and go about my business. So if I do that, so here's my x's. I'd add my exponents. Here's my y's. I'd add my exponents. Always think about money. If I owe somebody $6 and I borrow 3 more, now I owe them 9. But your answer should only contain positive exponents. So I got one more piece to play with here. X to the 12 is positive. Okay, we're happy with that. How do I fix the negative 9 on my y? We flip it. And flipping can go up or down. It doesn't matter. But wherever you flip the opposite makes it positive. And now I'm done. Because I can't put together x and y. They're different variables. They're different bases. So that's what we're looking for when we get to an answer. And I thought I'd do the doozy, because that's kind of a doozy, before we started to kind of move into some other areas. This is just me. Here, at least at the start, I'm going to ignore the top here for a second. I'm just going to do this. So here's my first time having to say this. It will be not the last. Big numbers don't play by exponent rules. That's not 3 plus 4. That's regular old 3 times 4. So 3 times 4 is 12. And I'm going to add my x's together. So negative 3 and negative 3 is negative 6. And don't forget that 1 on your y here. Y to the 3 plus 1 is y to the 4th. And it's decision time. Here's where I'm going to work it maybe a little bit different than I did the last one. I'm like, okay, I see, oops, I got to copy it right. That's my first issue. Okay. I don't like dividing with negatives because now you got a minus and negative and signs are changing and all this other stuff. So here's my suggestion. If I can get my pen to work, let's try this one. If it's a positive exponent, I'm leaving it alone. If it's a negative exponent, I'm flipping it. If it's a negative exponent, I'm flipping it. You're like, ooh, you can go bottom to top. You can. And y to the fourth is perfectly content and behaving well and being positive, so it gets to stay. That is going to make life a whole lot easier in a whole lot of ways. Because now, I'm not going to do this for a second. I'm just going to deal with these. Multiplying product, we're going to add the exponents. So 3 plus 6 is 9. Here, 4 plus 2 is 6. And reducing here, just be careful. It's not 12 divided by 3. It's 3 divided by 12. If you put that in your calculator with a little math, enter, we're going to end up here. Now, could I have just subtracted the exponents here? You sure can. It would go faster, but for some of you, I think it would really serve you well if you just worked and watched out for that. So that covers all of our basic exponent rules. So in that part, very first page of the notes, and we're good to go. Okay, any general questions or other ones we need to take a peek at before we move into that second part here, which I'm getting my notes situated for this. Go. Yeah, okay. I was going to say, if you want something ever, I'm absolutely willing to do it. Okay, simplify. You're like, what does that mean? So simplify, we are going to use our exponent rules, and I'm going to grab a calculator because I want to make sure I can show you this on there. We're still going to be multiplying exponents just like we were on the other ones, but the simplifying part will be a little bit different. Because this time we got variables and coefficients to work with. So, let's get down to business here. So all I'm going to do here is the number part I'm literally going to type in the calculator. 3 divided by 4. I want 625 to the 3/4. Bam. 125. And then here, we're going power to power, which is multiplying the exponents. 4 times 3/4. You are done. Keep life simple. The number, plug in your calculator. The exponents, just multiply them when you're going power to power. Not trying to do anything tricky to you there. Just working those through a bit. See what else we got working here. Oh dear. Oh dear, they're back. Rational exponents. All right, hang on a minute. So here's the good news. Okay. We're dealing with the same rules as the whole number exponents. So those rules we were looking on page 1 of your notes, if you want the actual rational exponents, they're on page 5 of your notes. But the rules aren't different, and you have examples to work with. So if we need that extra little bit of help, that's okay. Oh, what are we going to do with these? Let's do 14, and let's do 3 of these, actually. Let's just work down the left side. We'll do evens here. Right down the edge. Okay. Here's what I mean when I'm like, this is exactly the same. Big numbers don't play by exponent rules. 2 times 2 is 4. My u's. Okay, so I got u to the first and u to the 4/3. I'm going to be adding those together. And then I got these v's. Here's the great news. I don't need to go find a common denominator myself. I don't have to build fractions. I don't have to do nothing like that. All I got to do is take the exponent. Make sure you got parentheses on your fraction. Don't give me a decimal, though. That's the one thing I ask. Math, enter. Your answers are going to look weird. And it's going to make you doubt things. Don't doubt it. Don't doubt the process. Math, enter. Looks like that possibly couldn't be the answer. Oh, it is, though. It is. You just have to know the rule. Let the calculator do the work. Power to power. Okay, stuff with parentheses. We're multiplying the exponents. Again, I get myself help. If I know the basics, my calculator knows the rest. Four times -2 is -8. Be careful. Got to have positive exponents. So if you get to where you think you're at the end and you still have negative exponents, make sure. Oh, you get flipped. Oh, you get flipped. There's got to be something left up top. You can't just like leave it like this blank. So if there's nothing left up top, I've got to have a 1 up there. And it doesn't mean I flipped this one. It just means I have to have some way of showing whoever's looking at this, hey, these numbers are on the bottom of the fraction, not the top. And so I can fix that. And so basically as you do these, why do I keep going back to that pen? So 4 divided by 2 is 2. Now the rest of these, again, it's your call. I don't like negative exponents in divide, so I ain't dealing with them. So I'm flipping that down to the bottom. And that v to the 1's getting flipped. These don't need to be flipped. They're behaving themselves. They're being good. They're staying positive. So now all of a sudden, the 2 is on top, because 4 divided by 2 is 2, and 4 is bigger than 2. But everything else is on the bottom. So I'm going to add those up, because now it's not divide anymore. If you're on the same level, it's multiply. So we got u to the 19 over 6. And 1 plus 4/3. And we're good to go. So you can have exponents in the numerator, the denominator, as long as they're positive. Yes, sir. Sure. So lots of things with exponents here at the start to kind of play with. Okay, let's see here. We're still rolling. If we're looking back in our notes here, write the expression in exponential form. So you're like, okay, what does that mean? So we're kind of looking like we are here. Okay. So this is the part where we're going to do exponent over root. So I'm going to make myself a little note here. So here's how this works. I take a peek at this first one. I'm like, all right. So 5x, hardly do I need the parentheses around it. I do, because I want this happening to the 5 and the x. The exponent is right there. It's 3. What's the root if I don't see a little number here? 2. That's all you have to do. We're not multiplying it out. We're not distributing. We're not doing nothing. We're just changing the way it looks. And we're done. Keep life simple. Please, I beg of you. You're like, so that's it. That's it on that part. And when we go to radical form, it's the... Oops. When we go to radical form, it's the same idea. If there's something there besides your variable. Okay. It says radical form, so I guess I got to have a radical somewhere. The top number is still my exponent. The bottom number is still my root. As long as I have the parentheses. There's my exponent. There's my root. Again, Not long to get these done. Actually pretty straightforward. And so as I'm doing those, again, follow a couple simple rules, we're going to be all right. So the last part we're going to deal with today, it's like I said, we're going to break this into pieces. We kind of got options here. I'm trying to see which one I want to play with. Probably this for notes. Pages 10 through 12 probably gets us best. We're going to use different parts of it. Each graph represents a relation. Determine if the relation is a function. Here's the two things you're looking for depending on what you're given. If it's a graph, you're doing the vertical line test to see if it goes through your graph more than once. If you're given a bunch of numbers, you're looking to see if the x's repeat. We've got that right here in our notes. Actually, it's back on page 9 even. We're watching to see if it's 1-to-1. The better place, though, and that's why I mentioned page 10 here, talking about the numbers. We'll talk about that when we get there. Right now, I'm going to do my vertical line test. So any place I stop, I should only be going through one point in my graph. And as long as that's true, that's going to be a function. Okay? Domain and range. Now that's a little different of an animal. Domain and range, we're looking to see x values left to right. So I notice there's the furthest point to the left at -4. There's the furthest point to the right at +4. Now technically, I should use the bracket here and a parenthesis here. I'm not as worried about that. If you use brackets on both of those, I'm not going to ding you, okay? I want to see that you know the left to right part. And there's no arrows, so don't give me infinities yet. Arrows will be coming. Range, y values. Bottom to top. Well, the bottom of my graph actually is either of these points, but if I'm looking at it from y's point of view, the bottom would be at -1, +1, that is +1 right there, and here's the top. You're like, wait, but there's no point up there. It doesn't matter. Where's the top of the graph that's drawn? That's how we figure out the parts to this. So if there's endpoints on both ends, this is what your interval is going to look like. But, once an arrow comes in, it's on. So we still have a function. We're still passing the vertical line test. This time, though, here's my furthest point left. If I follow it back to the x-axis, I'm at -5 right here between -4 and -6. But that arrow right there, yes, it's going down, but it's also going right forever. Arrows are infinities, people. My range, bottom, forever bottom. To the top, that's not the top. Here's the top. Just follow it to get your y value. So if you have an arrow, something's going to be infinity. We just got to figure out what that little something is when we're looking at these. All right, let's take a peek here. We're almost to the end of what I'm deeming to be part 1. I don't want to drive you crazy on day 1. All right, 2 left for us to play with together. I'm going to play with 26 and 29. Okay. So I'm going through. You're like, Hardy, why are these all functions? Are they all going to be functions in the test? Probably not. Yeah, I don't know why I chose to do all these ones that are functions. Because this one is too. Now, if this graph were turned on its side, then it wouldn't be, but it's not, so. Okay. Arrows both ways. Do, 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 to the left, do, 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 to the right. Infinite domain. Range, it's going up forever. But there's my bottom right there. And it's not at -3. That's the x value. Follow it back to the axis. And get my range. So the last one we're going to play with today, like I said, we're going in pieces. Each table represents a relation. Determine... All right, hang on. I got to get my tables back out here. All the x values must be different. Page 10 of your notes. So if I'm doing this one, I have no cares whatsoever about y. Well, at the start, I don't. As soon as I see an x value repeat, it's not going to be a function. My domain is just listing off my x values. We're not doing intervals here. Okay? If they list individual numbers, we use the braces, that kind of squiggly line thing. And you don't have to write the same value if it repeats more than once. I won't mark it wrong if you do, but you don't need to. And then my range is just my y values when I do that. That'll actually end up being this very similar for... You gonna do it, Hardy? You're just going to the bottom of the page, aren't you? I am. I might as well. So we're gonna dig into part 2. I don't care. Same thing. So all I'm looking at here to figure out if it's a function or not is those 4 values. If they're all different, it's a function. Any repeats, it's not. My domain is just a listing of those values. And my range is just a listing of the y's. I'm hoping at some of those points, some of you are looking at this going, this test might actually be easy. This might not be bad, as long as I know my exponent rules. And it's true. So I come here to this last part, like, oh boy. All these arrows, this is kind of confusing. If you're confused with the arrows, I have a bit of advice. You always can just follow the arrow over and write all of these as coordinate points. Because then it's going to look a whole lot like what you just did on number 29 and 30. Now it's in a nice, easy way where I can look and say, hey, there's my x values. They're all different. That's a function. List off my x values. My range. List off my different y's and call it good. So actually, we made it through almost 2/3 of the review. But as you can see, except for the exponent problems, there's not a whole lot of work you have to do with these. You just got to know a couple of rules, and with the notes, that shouldn't be too bad of a thing to be able to do.